At this point, it might be interesting to take a look at another layer 2 protocol other than Ethernet to kind of compare how it works and how it deals with contention, and that's something we call token passing. Token passing is not Ethernet, so don't mix up the two. They have nothing to do with each other except that they're both layer 2 methods of dealing with contention. It's an alternative to Ethernet. It's often called the token ring. And here's how it works. The computers are all connected together. Each computer, as you can see here, has two NICs, two network interface cards on it, so that it is capable of connecting to two other computers. They're all connected together in a big physical ring, and this is the most typical way that token ring is made. And then we'll talk about this token in just a little bit. It can also be physically a star, so it can have a central device, as you see here in this picture, but that central device is communicating with one and then the other and then the other and so on around this ring. So logically it's a ring, but it can be physically a star topology. So how does it work? Well, it works this way. In order to avoid contention, it sends an empty frame around to each computer successively. PC1, PC2, PC3, PC4, and so on. And then when it gets done, it goes back to PC1, and it just sends this empty frame around. Now, when a computer wishes to communicate, it changes that token. When it receives the token, it changes that token to a non-empty token. In other words, it usually just adds a 1 to it. So now it's no longer empty. And then it sends its message to the desired recipient using a layer 2 address system. And once that recipient receives the message, then it's going to listen to the message, and then when that token hits that computer, the one that just heard the message, and it sees, oh yeah, this token is still loaded, it will empty that token again. So now it's now again an empty frame. And so then it passes on to the next one and so on. So this keeps going around in a circle. This way there's never contention because only one can talk at the same time. It's very similar to the old trick when you have an argument going on in the family and you have a thimble or a button and you pass it around, and only the person that holds onto that thimble can talk at any given time. Very similar concept, and it does reduce contention. So that's how token ring works. By the way, there is a version of token ring called FDDI, which is a fiber optic method of making a token ring, and it usually uses two rings, and they're counter-rotating rings, and the idea of the two rings is that now you have redundancy. So if notice that this is a serial signal. In other words, it's like one big wire. If there's a break in one of these rings, none of the computers can talk. But by adding that second ring, you have redundancy now, so that if one ring goes down for some reason, one of the NIC cards goes down, you now have another one that you can rely on. Well, that's it for token ring, but in the next video we're going to compare and contrast a little bit about the response levels of token ring versus Ethernet.